To start with, look at page 131 in your Algebra 2 book. To use a certain computer database, the charge is $30 per hour, daytime, and $10.50 per hour at night. That used to be true. You would pay a different rate for things at night versus during the day. Electricity, for example, it's cheaper at night. If a research company paid $411 for 28 hours of usage, find the number of hours charged at the daytime rate versus the nighttime rate. This is a prime example of a system, okay? And you're going to have to solve it that way. Some people can figure it out using only one variable, but I find using a system to be the easiest way. So daytime hours and nighttime hours. I'm going to use what they're using as well. Okay, and they're charged at a different rate. Okay, so we know that the total hours that he was charged, day and night, equals 28, right? If you look in this scenario, it says he used it for 28 hours. That's also when he paid the $411, but we don't know how much of this plus how much of that gave us the $411, which is why we're separating it into a system. We also know that the charges, it is $30 per hour during the day and $10.50 per hour at night. $30 an hour times the hours of day, $10.50 an hour times the hour of night gave us the $411 that the guy actually spent out of pocket. Okay? That being said, we have a system. Okay? Now, you guys have been taught two ways. You've been taught substitution and linear combination. Whenever the coefficient of a variable is already a 1, I highly recommend using substitution. Okay? This particular equation, for example, they solved it for D. They said D equals 28 minus n. And that makes sense. If the total is this, and we remove the nighttime hours, we get the number of daytime hours. Ask if you have a flash drive, if they have one for you. Okay, so I can take this value right here and substitute it for what daytime for the D in the other equation, which gives me the following. 30 times what I solved D to be, which is 28 minus n, added to 1050 times n, all together equals $411. So we used substitution. Okay? We used substitution there. We can solve from there, ending up with 840 minus 30n plus 10.5n. Collect like terms. Negative 30n combined with a positive 10.5, you end up with what? Negative 1950? As far as your n's are concerned. And we know we're going to have to move, well, I'll leave it like that, and I'll move it in a separate step. But some of you can probably do it all in one step, but we know we want variables on one side, and we want constants on the other. So I'm going to move that 840 over to get to where I have negative 1950n is equivalent to negative 429. When they divide, they get the number of nighttime hours is 22. Okay? If the number of nighttime hours is 22, how many is daytime? 6? Makes sense. Night is 22. Day is 6. Total is 28. Okay, so there's our answer. Pretty good. Okay. This is also very, very useful for aeronautics and engineering. Aeronautics is flight, okay, and any type of flight. It could be airplanes, helicopters, rockets, kites, all right? It doesn't matter what kind of flight we're talking about. Speed of any type, those are also very, very useful. So look at the bottom, airspeed, wind speed, tail, head, and ground speed. Okay, if any of those don't make sense to you, look at the definitions. Okay, airspeed is when it's flying. Wind speed, Captain Obvious, it's the wind. Okay? Tailwind is what blows behind the aircraft, pushing it along. Okay? Tailwind is good for an aircraft. It helps it. In contrast, headwind is what blows against the aircraft, forcing it to work harder or go slower. Okay? And ground speed is that speed that it has when its wheels are still on the ground prior to take off, right near the ground. And it also means in relationship to the ground. Okay? Take a look at page 132. This is where it gets a little scary. These were my least favorite types of equations when I was your age. And now I like them. How funny is that? All right. Example 2. Here we go. Example 2 says, to measure the speed of the jet stream, which the jet stream, you guys know, is the upper atmospheric west to easterly wind. And if you ever watch the weather, they usually show like this swoop. All right, and depending upon the speed, different things happen with our weather. Okay? To measure the speed of the jet stream, a scientific plane flew for 1,800 kilometers with the jet stream as a tailwind, so pushing it, and then it turned around and went the 1,800 miles back against the wind. Okay? The eastbound flight took 2 hours, and the westbound flight took 3 hours, 20 minutes. What are the speeds of the jet stream and the speed of the plane? Whew, boy. Okay, let me try and straighten this out for you guys. All right, you guys have already learned that the rate times the time something is moving is equivalent to the distance the item is able to travel, right? All right, does that make sense so far? So eastbound is good, and I'm going to call it good, and I'm going to say it's with the help of the wind. Okay? Eastbound is good. It's like having someone pushing you when you're trying to run. Okay? Having someone shoving you along, you're going to go faster. Okay? In contrast, the western bound trip is, and I'm going to call it bad, because it is against the wind. If any of you soccer players ever had a soccer practice where you were running and the wind was blasting you in the face, you can feel the difference in your ability to run. All right? So that being said, we are still going to solve this like a system. We've got two things producing travel. We've got the plane itself, and we've got the W, the wind. Okay, so the plane, the P, is producing its own airspeed with its engines, and the wind is either helping it or hurting it. Okay, so P for speed, but I think of it as the wind's, or the plane's ability, and W for the wind's ability. Okay, if you combine those things, and they're calling it ground speed, but I'm just going to call it speed. If you combine those things, when the guy is going eastbound, it's together. They're working together, right? The jet is firing, the wind is pushing, and the plane is doing really, really well. Okay? That particular combination is a positive combination. okay? Multiply that by the 2 hours, and you get 2p plus w, okay? In contrast, a plane producing the same amount of speed is going to be slowed down by the wind. The wind will have a negative impact on the plane. And that plane going back against the wind took 3 1/3 hours. Much longer, right? 3 1/3 hours. And I am going to turn that into 10/3. Okay? So the distance traveled, even though it's the same thing, is reflected this way. Okay? However, both of these distances are 1,800 miles, right? Going there, I had a tailwind, I was feeling good, 1,800 miles under my belt. Turning around, going back, I felt like I was working to death, 1,800 miles under my belt, okay? So the distance traveled with the tailwind, rate times time equals distance, can be written this way. 2 times p plus w equals 1,800. It did equal 1,800. We already know that, okay? So this is width. Against was 10/3. P minus W is 1,800. What we want to know is what the plane's speed was, and we want to know what the wind speed was. Okay? The wind helped us going out there and hurt us coming back. All right? Now, here's our system and our 2 equations. What they show us under solve the system is that when we start with 2p plus w equals 1,800, rather than distributing the 2, you can divide both sides by 2 and reduce the equation to p plus w equals 900. Okay? You can reduce the equation that way. That's nice. My coefficient is 1. All right, the other equation, 10/3 times p minus w is equal to 1,800. This equation, if I multiply both sides by 3, I am able to cancel out my fraction. I'm sorry, 10/3. 3 over 10. We'll do it that way, 3 over 10, because then I'd still have to deal with this mess. You will end up with P minus W, and then if I multiplied 1,800 times 3 and divided it by 10, you end up with that. Okay? Multiply both sides by the reciprocal of 10/3. Combining this mess, well, I already have 2 that are opposite of each other. Oh, sorry guys, let me move up a little more. Lucky for us. So adding these systems together, 2p equals 1,440, so p is going to equal 720. Okay, 720. 720 for the plane speed plus what is 940? Looks like it's 180, isn't it? So because I know the P, I know that W equals 180. Okay? So far so good? All right. Whew. Okay. I have a couple of more examples for you, but I'm going to stop and start over because I have no more time on this one.
Is it really a liar?